Good morning, students. Welcome back to the session on fundamentals of cloud computing. Today, we will study about grid computing and service-oriented architecture. First, we will learn about what is meant by grid computing. So, grid computing is also known as distributed computing. It can be defined as a network of computers working together to perform a task that would rather be difficulty for a single machine. All machines on that network work under the same protocol to act like a virtual supercomputer. The tasks that they work on may include analyzing huge data sets or simulating situations which require high computing power. Computers on the network contribute resources like processing power and storage capacity to the network. Grid computing is a subset of distributed computing where a virtual supercomputer comprises of machines on a network connected by some bus, mostly Ethernet or sometimes the Internet. Grid computing consists of three types of machines. Control node is a computer, usually a server or a group of servers which administrate the whole network and keep the account for the resources in the network pool. Provider, the computer which contributes its resource in the network resource pool. User, the computer that uses the resource on the network. When a computer make a request for resource to the control node give the user access to the resources available on the network. When it is not in use, it should ideally contribute its resource to the network. Hence, a normal computer on the node can swing in between being a user or a provider based on its needs. The nodes may consist of machines with similar platform using same operating system called homogeneous network, else machine with different platforms running on a various different operating systems called heterogeneous network. Mainly, grid computing is used in ATM, back-end infrastructures, and marketing research. Grid computing system requires at least one computer, usually a server, which handles all the administrative duties for the system. Many people refers to this kind of computer as a control node. Other application and web servers provide specific services to the system. Networks of computer running special grid of computing network software. This computer acts both as a point of interface for the user and as the resources. The system tap into for different applications. Grid computing system can either include several computers of the same make running on the same operating system or different computers running on every operating system imaginable. The network can be of anything from a hardwired system where every computer is connected to the system with physical wires to an open system where computers connect with each other over the internet. Collection of computer software called middleware. The purpose of middleware is to allow different computers to run a process or application across the entire network of machines. Middleware is the workhorse of the grid computing system. Difference between the cloud computing and grid computing. So cloud computing follows client server computing. Grid computing follows distributed computing architecture. Scalability is high in cloud computing. Scalability is normal in cloud computing. Cloud computing is more flexible than grid computing. Grid computing is less flexible than cloud computing. Cloud operates as a centralized management system. Grid operates as a decentralized management system. In cloud computing, cloud servers are owned by infrastructure providers. In grid computing, grids are owned and managed by the organization. Cloud computing uses services like IaaS, PaaS, and SaaS. Grid computing uses systems like distributed computing, distributed information, and distributed pervasive. Cloud computing is service oriented. Grid computing is application oriented. It is accessible through standard web portals. It is accessible through grid middleware. Service-oriented architecture. Service-oriented architecture, SOA, is a group of services which can transfer data within each other. This data transfer can be either simple data processing or some activities. The service-oriented architecture does not depend on other services. The service-oriented architecture is also known as application structures, which divides the business application into a particular business procedures and functions. The service-oriented architecture plays the commitment and expenses of deployment. Service provider and service consumer are the two major roles in service-oriented architecture. Service provider. The service provider is the maintainer of the service and the organization that makes available one or more services for others to use. To advertise services, the provider can publish them in a registry. Together with the service contract, it specifies the nature of the service, how to use it, the requirement for the services, and the fees charged. Service consumer. The service consumer can locate the service metadata in the registry and develop the required client component to bind and use the services. Service-oriented architecture is an architectural approach in which applications make use of services available in the network. SOA allows the user to combine a large number of facilities from existing services to form application. SOA encompasses a set of design principles that structure system development and provide means for integrating components into a coherent and decentralized system. SOA-based computing packages functionalities into a set of interoperable services which can be integrated into different software system belonging to separate business domain. The below figure shows the service customer sends the message to a service provider. After the service provider returns the request to the services consumer. Here the service provider can also be a service consumer. Guiding principles of service-oriented architecture. Standardized service contract. A service adheres to a service description. Service must have some sort of description which describes what the services is about. This makes it easier for client application to understand what the service does. Loose coupling, less dependency on each other. This is one of the main characteristics of web services, which just states that there should be a less dependency as possible between the web services and the client invoking the web service. So, if the service functionality changes at any point in time, it should not break the client application or stop it from working. Next, service abstraction. Service hide the logic they encapsulate from the outside world. The service should not expose how it executes its functionality. It should just tell the client application on what it does and not on how it does it. Service reusability. Logic is divided into service with the intent of maximizing reuse. In any development company, reusability is a big topic because obviously one could not want to spend time and effort building the same code again and again across multiple applications which require them. Hence, once the code for a web service is written, it should have the ability to work with various application types. Service autonomy. Services should have control over the logic. They encapsulate the service, known everything on what functionality it offers, and hence should also have complete control over the code it contains. Discoverability. Services can be discovered usually in a service registry, which performs a registry which can hold information about the services. Composability. Using services as a building blocks, sophisticated and complex operations can be implemented. Service orchestration and choreography provide solid supports for composing services and achieving the business goals. Advantages of SOA. Service reusability. In SOA, applications are made from existing services. These services can be reused to make many applications. Easy maintenance. As services are independent of each other, they can be updated and modified easily without affecting other services. Platform independent. SOA allows making a complex application by combining services picked from different sources independent of the platform. Availability. Service-oriented architecture facilities are easily available to anyone on request. Reliability. SOA applications are more reliable because it is easy to debug small services rather than huge cost. So, scalability. Services can run on different servers within an environment. This increases the scalability. Disadvantages of SOA. High overhead. A validation of input parameters of services is done whenever services interact with this decreased performance as it increase load and response time. High investment. Huge investment is required for service-oriented architecture. Complex service management. When service interact, they exchange messages to tasks. A number of messages may go in millions. It becomes a cumbersome task to handle a large number of messages. Applications of service-oriented architecture. These are the following applications of service-oriented architecture. Service-oriented architecture is used to improve the healthcare delivery. Nowadays, many apps are games and they use inbuilt functions to run. For example, an app might need GPS, so it uses inbuilt GPS functions of the devices. This is a SOA in mobile solutions. And SOA infrastructure is used by many armies and air force to deploy situational awareness system. SOA helps maintain museums a visualized storage pool of their information and content. Okay, students, with this we come to an end of the session of service-oriented architecture and grid computing. Thank you, students.